Alright, so let's continue on with 2.4, angle properties in polygons. Now a polygon is a shape. We have different types of polygons, different shapes with different numbers of sides. The most common ones are a triangle with 3 sides and a quadrilateral with 4 sides, but we also have other polygons such as a pentagon, hexagon, heptagon, and octagon. Alright, so we're going to discover the relationship between the interior angles of a polygon and the number of sides of the polygon. So a triangle's got 3 sides, one triangle, because it's just a triangle, so the sum of the measure of the interior angles is 180 degrees. A quadrilateral has got 4 sides. Now it's got 2 triangles, and the measure of the interior angles are 360 degrees. Okay, what do we mean by that? Well, a quadrilateral is a 4-sided shape. It could be a rectangle or a square, but it doesn't have to be. So if we draw diagonals, we see that a quadrilateral has got 2 triangles there. Alright? So the sum of all these angles in here equals 360. Okay, a pentagon has got 5 sides. The number of triangles it has is 3. So the interior angles of a pentagon are the number of triangles times 180, so it's going to be 540 degrees. So if we look at a pentagon, it's got 5 sides, it's got 5 interior angles, 1, 2, 3, 4, 5. We're able to draw 3 triangles inside the pentagon. There's one triangle, so 1, 2, 3 triangles inside the pentagon. So therefore, adding up all these interior angles together gives us 540 degrees. Okay, so let's go in and fill the rest. The hexagon has got 4 triangles inside, so the sum of its interior angles is 4 times 180. Which is 720. And then a heptagon's got 5. And 5 times 180. Alright, so as you can see, as we increase the number of sides of a polygon, the number of triangles increases by 1, and the sum of the interior angles increases by 180 degrees each time we add a side to the polygon. Okay, let's make a conjecture about the relationship between the sum of the measures of the interior angle of a polygon, which we'll call S, and the number of sides of a polygon, N. So I want you to think about that. Remember, conjecture means a prediction. So what is our prediction going to be? Think about that. I'll give you a second. So the number of triangles in a polygon is 2 less than the number of sides. Alright, so if we go back up here and we look, we have 1 triangle in a triangle. It's got 3 sides. In a quadrilateral, we can draw 2 triangles. In a shape with 5 sides, we can draw 3 triangles. So the number of triangles that you can draw inside a polygon is always 2 less than the number of sides of that polygon. Alright, now let's write an equation for this, remembering that S means polygon and N means the number of sides. So knowing that, we can write this equation. So the sum, S, of the interior angles of a polygon is equal to 180 times the number of sides of that polygon take away 2. S equals 180 times N minus 2, where N is the number of sides. Or, if we write in function notation, S of N equals 180 N minus 2. These pretty much, they mean the same thing. So don't worry too much about that. Now let's use our prediction here above, our equations, to verify the sum of the interior angles of a dodecagon, which has 12 sides. Okay? So there's a dodecagon, and it's got 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12 sides. Now, how many triangles can we draw within a dodecagon? Alright, well, let's try and figure it out. I'm going to use a different color for this, say yellow, maybe green. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So we can draw 10 triangles inside this dodecagon. So the sum of the interior angles is going to be 10 times 180, which is 1800 degrees. Now, it's very time consuming to draw triangles inside shapes all the time, so let's try and do it with the formula. So our formula is the sum of the interior angles equals 180 times the number of sides of the polygon take away 2. Now it's a dodecagon, it's got 12 sides, so S equals 180, 12 minus 2. So the sum of the interior angles is basically 180, 12 minus 2 is 10, and 1800 degrees. So we come to the same answer, alright? Whether using the formula or drawing the interior triangles inside the polygon. Alright, let's look at some examples. Let's look over here. We see that an exterior angle is an angle formed by two lines outside of the polygon, on the outside of the polygon. And this is on the opposite side, the supplementary angle is called the adjacent interior angle. Alright, so here we have a rectangle, and it's drawn that it has one exterior angle for each interior angles. Determine the sum of the exterior angles. So if we zoom in a bit on this rectangle, we see that we have little squares there. Okay, those indicate that it's a rectangle and that these lines right there are perpendicular, so they form 90-degree angles. So we have 4 90-degree angles. Right? We know that along a line, the angles are supplementary, so they have to add up to 180. So if this is 90 right there, that means that the exterior angle also has to be 90 degrees for it to add up to 180. And same here, and here, and here. So the sum of the exterior angles is 90 degrees times 4, which equals 360 degrees. Okay, so measure the interior and exterior angles in the regular quadrilateral below. Well, I've given you the interior angles, so we're going to try and discover what the exterior angles here, here, and here are to this quadrilateral. Alright, so let's zoom in on the quadrilateral a little bit. Okay, so again, we're going to use the supplementary rule, knowing that this whole angle right there has to add up to 180, then this angle here is going to be 180 minus 63, which is 117 degrees. In here, Z, D and Z both add up to 180. So Z is 180 minus 147, which equals 33 degrees. And here again, both these angles W and A add up to 180. A, though, is 67 degrees. So W is going to be 180, take away 67, 113 degrees. And X is going to be, by the same process, 97 degrees. And that's how we figure out the exterior angles of this polygon, given that we have the interior angles.